So today we are going to solve LeetCode problem this, that one, LeetCode problem 2958, length of the longest subarray with at most k frequency. Okay, so let's understand the problem. So what is the problem? Asking, we are given an array called nums and an integer k. Okay, so we have to find the longest continuous subarray where every element appears at most k time. So okay, now what is mean by subarray? See, subarray means a continuous part of the array. We cannot skip any element. Okay, so let's see, if we have nums of array 1 2 3 4. Okay, so the subarray are 1 2 2 3 3 4 1 2. Oh, sorry, if we have subarray 1 2 3 4 1 2 3 4. Okay, then 1 2 2 3 3 4 1 2 3 2 3 4. Yes, then 1 2 3 4. Okay, so this are subarray. If we can write 1 3, this is not valid subarray. Okay, it was invalid because we are skipping 2. We can, here we are not skipping any element. Okay, it was continuous subarray. So now what is mean by at most frequency means, suppose we have k is equal to 2. Okay, it means every numbers can appear at most 2 times. Okay, see, 1 2 2 3. So let's count. 1 has appears 1 time, 2 has appeared 2 times, and 3 has appears 1 time. Okay, so everything is greater than 2, greater than or equal to 2. Now, so this is a valid subarray. Okay, but wait, we have 1 2 2 1. Here 2 has appears 1 2. Let's take 1 2 2. Okay, here 2 has appears 3 times. Okay, and 1 has appeared 1 time, but our k is 2. So what can we do? It was invalid. Okay, no, yes, see, here k is 2 and 3 has appears 2 has appears 3 times, but it was not valid. If we have 1 2 1 3 and k is equal to 2, so let's check the whole array. For see, 1 has appeared 1 time, 2 has appears 1 time, and 3 has appears 1 time. Sorry, 1 has appears 2 times. Okay, it was valid. Every number has appeared at most 2 times, so the whole array is valid. Okay, the whole array was valid. So the answer is 4. Okay, 1 2 3 4. Now let's take one more example. 1 1 1 2 and k is equal to 2. So we can take the whole array. We can take the whole array. Let's check, k is 2 and 1 is appears 3 times. We cannot take the whole array. We can take this much array only. Okay, it was, whole array was not valid, so we take a smaller continuous subarray, that was 1 1 2, because here 1 has appears 3 times and 2 has appears 1 time. Our k is 2, so we cannot consider full array. We just take this much array, continuous array, that was 1 1 2. Clear? Now let's take one more example. 1 2 2 3 3 2 4 and k is equal to 2. Okay, can we take the whole array? Let's count. 1 has came 1 time, 2 has came 1 2 3 times, so 3 has came 2 times, and 4 has came 1 time. So our k is 2 and our 2 has came 3 times. So can we consider full array? No, we can just take this much array only. Okay, this much continuous subarray we can take, that was 2 3 3 2 4. 2 also has came 2 time, k and 3 also came 2 time, 4 has came 1 time. Okay, so the answer is 1 1 1 2 3 4 5. Got it? Now see, That's it. So the main idea of the problem is very simple. We need to find the longest continuous subarray where no number appears more than k times. For example, see, if k is 2, a number can appear 3 times, 1 2 3. Okay, if the number has if the number can see, if for example if k is 2, a number can appear one time or 2 times, but if appears 3 times like this, so that subarray becomes invalid. Okay, also remember that a subarray must be continuous. We cannot skip element. Now that we understand the problem, let's think about how we solve it. So let's take small example. 1 1 2 and k is equal to 1. Okay, so we need the longest valid subarray. See, think about a window. Instead of creating every possible subarray like this, like this, we will maintain a window. Okay, we will maintain a window and a pointer. Okay, left and right, we will call them left and right. See, we move right. Okay, the right pointer we move from the left to right and add element into our window. See, first window becomes this, then we move right, so we check one frequency is 1, so our k is 1, it was 1, so this is valid. Now we move right, comes here, now our window become 1 1. Okay, so one frequency become 2, so but our k is 1, so it was invalid. So 1 is less than 2, so the window is invalid. So what we do, we move left pointer. Okay, now left comes here, we remove this element. So from this window we remove this element and our window become like this 1. Now it 1. When the window become invalid, we move the left pointer from forward and remove element from the window until the window become valid again. Got it? So it was right again. So let's continue. Now we move right pointer, right comes here, now our window is 1 2, so 2 frequency is 1 and 1 frequency is 1, so it was valid. Okay, so the answer is 2, both are less than k, so it was valid and the answer is 2. Okay, main sliding window idea is, so the right pointer extend the window, and whenever the window becomes invalid, the left pointer shrink the window. So this way we do not generate every subsets. For this way we do not generate every subarray, we maintain only one window and keep it valid. So see here, we do like this, right moves, okay, then we add element, then we update frequency, then see, frequency is less than k. If yes, we move left. If no, we calculate the length. So next, window valid. Okay, so now we have understand the idea. So let's write down the code. We have the nums array 1 1 2 and k is equal to 1. See, we need a map. First we need to store how many times each number appears inside our current window, so we use an unordered map. Okay, so let's write down the code. First we need a map, unordered map, and okay, so see, if it's look like this. For example, we have 1 1, frequency of 1 is 2. Okay, 1 has appears 2 times. Then we need, next we create a left pointer. Initially we start from index 0 only, so So we need a left pointer also. Let's write left is equal to 0. Then see, we also need a variable called answer or result to store the maximum rent, okay, of a valid window. That's why we write int a and x is equal to 0. Now we write, say, for int right is equal to 0 and right is less than nums dot size, then right plus plus. See, now we use the right pointer to extend our window. The right pointer move from the left to right to the array. Here we are moving like this only, okay. Where is that example? See, now right is here, then right comes here, then right comes here, okay. So now we have to add the current number inside the row whenever the right pointer reach a new element, okay. We add that numbers to our frequency map also. Nums right plus plus. Now see here, now right is equal to 0, nums of right is equal to 1, okay. So here FYEQ of 1 plus plus, now 1 become 1, then right is equal to 1, so in nums of right there is 1, now we increase this range frequency, now 1 become 2, okay. We have to check window become invalid, so the most important part, now we check whether the frequency of the current number has become greater than k. So that's why we write while q of nums then right is greater than k, okay. See here, our k is 1, now our window is 1 1, so frequency of 1 is 2, so 2 is less than 1, no, so the window is invalid, okay. So then we inside the while we do, see this, if the window is invalid we remove the leftmost element from the frequency map q of nums of left minus, okay. So it become 1, then left, we move left forward. After removing the leftmost element we move the left pointer one step forward, okay. Then we will calculate after the while loop, answer is equal to max answer right minus left plus 1, okay. See, now the window is valid, so we calculate its length and update our maximum answer, okay. So why we have write this right minus left plus 1, because both index are included, okay. Left is 1 and right is 2. See here, now left is 1 and right is 2, okay. So 2 minus 1 plus 1 is 2, so the length is 2, okay. In last we just return our answer, okay. So after processing the complete array we return the maximum length, frequency map, left and right pointer, for row. So let's run this. Yes, see, so the main idea is light expand the window, and when the frequency become greater than k, left shrink the window until it's become valid again, okay. Finally we keep the maximum window length as our answer. That's it. And the time complexity is big O of n, and space complexity also big O of n. Time complexity is big O of n, space complexity is big O of n. So this is our answer. So it's work. That's all.